Right, so it looks like it's working. Right, plug him in. That'll power up the Arduino. Right, so I should be able to control the milling machine just from the Arduino. Let's put in one and do jog, sine wave, test, and I can go back, and that says ODrive idle. So the ODrive needs to be in closed loop control mode. So I'll get back on there and then put that into closed loop control. Now that's in closed loop control, I haven't got a back, but I can turn it back off again if I wanted to. So I can go into to jog it, and I can jog and record the Y position. So by 1mm, 10mm, or 100mm. This will be a lot quicker when it's on a battery out the front, but I'll do that a little bit later anyway. So put that one back. So 9, let's cancel that one, cancel that one, cancel that one. Then what I can do as well is cancel out of that, I can go sine cosine. So if I had another axis on here, this will actually be doing the cosine, because that's doing this sine. Yep, that's doing the sine, so that will be doing the cosine, so I'll be drawing a circle. I haven't allowed for backlash yet, but I'm going to measure that on here in any case. And then I'll put that in the program, so I'll make sure that the backlash is taken up every time it changes position. When that finishes, it does 5 revolutions. So, and then it's back to this. And if I go into jog mode, it should be back on 0 again. So that updates, but it's kept in the Arduino's memory. So if this changes, the system knows exactly where it is. So if I come out of that, so if I take the Joypad, turn it on at the side, I can then access, so I can do the brightness on that little dot. And there's a reason why I've got this dot, because I was away at the weekend and couldn't take the milling machine with us. So I put this on the Arduino so I could see every dot movement is 1mm of movement on here. So effectively that was my milling machine. Try not to crash it. So I can adjust the speed on that. That's on 35.5501. So if I go turn that off, hand control back over to this, go back into jog mode, and now I've got 35.5501, and I can jog that by 1mm, 10mm. And if I go out of jog mode, back into control for the joystick, you can see I can adjust that. And that's variable as well, so I can move it very slightly or quite fast. And if I want finer control, I've got a variable resistor on there, So I can ramp that down a bit. You'll see that very slightly moving. So that's the maximum on the lowest, but I can actually increase the speed of that. By using this variable here. So I'll bring that back down. As I say, this will go a lot quicker when it's on a battery. But as you can see, it's very responsive. Like that on there. Turn that off. This is past the control back to that. But if I turn it on, you can see that it flashes. So this is on every time this has got control of the machine. So I turn that off, it puts control back to there, and then this will run whatever program I need it to run, even a G-code, so I haven't put it in yet, but I'll put in the program to accept G-codes and then convert it and then move the milling machine accordingly, also taking into account the backlash on it as well. ODrive tool. V. C. Control V. Thanks on that one. That should start up. Yep. Right, let's put that in full screen. Let's see that. Turn that off. Back on there and calibrate. So you should see on here this calibrating. So it's calibrated and then it jumps back up to 0 position, so that's in the program. That goes to 0, because otherwise when I turn this on it jumps to 0. So turn this one on, and that's on very slow, so you can see that that's moving by a tiny amount, but it is following it, as you can see from the ODrive there. In fact, I'll move that camera. So obviously this is going to be the movement. That's the display for that program. That shows each millimeter that moves. And then this displays the voltage that it's currently on and how much current it's pulling. So at the moment it's pulling 100 milliamps. So right, let's have a look. So I can move it a tiny amount. It's just tracking that. I can speed it up a bit. Against backstop. That doesn't cause it any damage whatsoever, just knocks the paint off the back. If I go too fast, you can see that the motors are not catching up with the demanded position. As soon as I let go, it catches up. It's the same with the other direction as well. It's trying to catch up, but it's not quite fast enough. But it will be once the battery's on, and I can speed this up to 350,000, I think it is. If I put that in sine, should be able to see the sine wave coming on there as well. And this is pulling about 200 milliamps for 13 volts. Right, let's go and smash out some milling. Oops, there's an error there. Yeah, motor fail, current unstable. That's probably that connection there. Zero calibrate. There's your calibrates. Jeez. No, didn't like that. Unstable. Probably because of that connection, but we'll go for a slow speed anyway. Position. That needs to change. So it's going to be 4, let's change it to 10. So it's 16. Divide by 16, divide by 60. That's 12. Hold that as still as I can. Jog it. That's 1 mil. Jog it back. Now keep going. Yeah. Nice. So if I jog that 10 mil from there, so me moving it is a nightmare. Right, 10 mil at a time. Oops, no. Like that, lots of current there. That way. Right, time to do some milling with it. I think that's pretty good. Right, I'm going to have to stop this recording because the battery's dying. So I'll do a bit more of this and then I'll record some more at a later date.